Okay, this is lesson 4, arithmetic sequences and series. Our essential question is, what is an arithmetic sequence and how do you represent and find its terms and their sums? Okay, our table of contents. Define an arithmetic sequence. So a sequence is a function whose domain is the natural numbers. An arithmetic sequence is a sequence with a common difference. So either I'm adding the same number or I'm subtracting the same number every single time. A geometric sequence is a sequence with a common ratio. So I'm multiplying the number by something, or I'm dividing that number by something. So in our examples here, I've got -1 to 1. I'm adding 2. So every time I'm going to add 2 to that sequence. A geometric sequence, I'm multiplying by 3. So 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, so on and so forth. Okay. Understand arithmetic sequences. So is the sequence arithmetic or an arithmetic sequence? If so, what is the common difference? What is the next term in the sequence? So I'm going from -6 to -3 to 0 to 3. So in this case, it is an arithmetic sequence. I'm adding the same number every single time. My common difference is adding 3 or plus 3. Okay, so then in order to figure out the next term in the sequence, I take the last term that I have, which was 3, and I add 3 to it, which gives me 6. Okay. Write the following as a recursive and explicit definition. Okay, so an explicit definition is where I take a sub n, which equals a sub 1, my first term in my sequence, plus d, my common difference, times n minus 1. For my recursive definition, I have a brace, a sub 1, so whatever my first term is when n equals 1, and then a sub n minus 1 plus d, my common difference for any term that's greater than that first term. Okay. Explicit, we need to know the first term, a sub 1, and the common difference. We know our first term is -6 in this case, and our common difference is +3. Okay, so then I can write the explicit definition. A sub n equals -6 plus 3 times n minus 1. Okay. The only thing that you're substituting in is that a sub 1 and the d. Recursive, we need to find the first term, again, a sub 1, and the common difference, which is -6. And I substitute those values in for a sub 1 and d. Okay, so I get a sub n equals -6 when n equals 1, and a sub n minus 1 plus 3 for any number that's greater than 1, for any term that's greater than 1. I can translate between recursive and explicit forms. So given the recursive definition of 3 when n equals 1 and a sub n minus 1 plus 0.5 when n is greater than 1, what is the explicit definition for the sequence? Okay, so we need to locate a sub 1, or our first term, and we need to find what the common difference is. In this case, a sub 1 is 3, our first term is 3, and our common difference is 0.5. We then substitute those values into the explicit definition. This will give us 3 plus 0.5 times n minus 1. Okay. I can also go the opposite way where I'm going from explicit to recursive. Okay. I'm going to do the same thing. I'm going to locate my a sub 1s, in this case 16, and my common difference, in this case -3. Okay. Then I'm going to use that information and I'm going to substitute it into my recursive definition. So a sub n equals 16 when n equals 1, and a sub n minus 1 minus 3 when n is greater than 1. Solve problems with arithmetic sequences. Okay. A high school auditorium has 18 seats in the front row and 26 seats in the fifth row. The number of seats in each row forms an arithmetic sequence. What is the explicit definition for the sequence? So they told us in the original problem that there are 18 seats in the first row. That's my a sub 1 value. That's the first term in my arithmetic sequence. I also know that in the fifth row, so a sub n or a sub 5, because it's my fifth row, there are 26 seats. So we know that we are looking at the fifth row where n equals 5. We're going to substitute the values that we know into our explicit equation. So we know a sub n equals 26 or a sub 5 because we're looking at the fifth row. A sub 1 is 18 and our n value equals 5. We're trying to figure out what the common difference is. Okay? So I substitute 26, 18, and 5 in for a sub n, a sub 1, and n respectively. Okay? So 5 minus 1 gives me 4. I subtract 18 from both sides of my equations, and then I divide by 4, so I get a common difference of 2. So in my first row, I had 18 seats. In my second row, I'm going to have 18 plus 2 seats, or 20 seats. In my third row, I'm going to have 20 plus 2, or 22 seats, and so on and so forth. Okay. So then I can write the explicit definition of a sub n equals 18 plus 2 times n minus 1. Okay. I can substitute the values into the explicit definition or explicit equation. Again, a sub 1 is 18. I want to know how many seats are in the 12th row. So I put 12 in for n, and I put d equals 2 because my common difference was 2. Okay, and again, I substitute those values in. So I'm looking for a sub 12. Okay, so a sub 12 equals 18 plus 2 times 12 minus 1. 12 minus 1 is 11. 11 times 2 is 22. 18 plus 22 equals 40. So the 12th row has 40 seats in it. Now you could go through and go, okay, first row has 18, so 18, 20, 20, and you could count up, okay? This is just a slightly faster way to do it, especially when you're dealing with larger amounts of numbers as well as larger values of n and more terms in your arithmetic sequence. Next, we're going to find the sum of an arithmetic series. So a finite series is the sum of the terms in a finite sequence. So finite literally means it's ending. So it has a beginning and an end to it. So in this case, what is the sum of the following arithmetic sequence? 2, 6, 10, 14, 18, 22. If you want to, you can sit here and add 2 plus 6 plus 10 plus 14 plus 18 plus 22. But when you get into larger and larger sequences, you're going to want to know the formula for it. So my formula for sum of a series is S sub n, which is the sum of the terms. So that's going to be my answer, my solution, equals n, however many terms there are in the series, times my first term plus my last term, and then divided by 2. Okay. So I know my first term is 2. So a sub 1 equals 2. My last term in my sequence is 22. And I know that there are 6 terms in the sequence. So I substitute those values in for n, a sub 1, and a sub n. Okay. So I get 2 plus 22, which equals 24. 24 times 6 gives me 144, and 144 divided by 2 gives me 72. So in this case, there's 70. The sum of the sequence is 72. You may also see it as sigma notation, okay, which is this Greek letter. It kind of looks like a capital E. So sigma notation, okay, the I equals 1 at the bottom tells which term I start at. Usually you'll start at term 1, but not always, okay? N tells me how many numbers are in that series, and A sub I tells us the rule of the series. Okay, so I want to know what the sum of 2i minus 6 is from 1 to 9. Okay, so I'm looking at the first term in my series, and I have 9 terms in my series. That's what the 9 tells me. And my rule is 2i minus 6. Okay, so I determine if I want to find the sum of the first and last term and use the sum formula, or if you want to substitute the values for each term in and then add the numbers together. Okay. The explicit formula works, especially for long sequences, while the sum method is better for shorter sequences. So if it was 1 to 3 or 4 numbers, I probably would just use the sum formula, or I probably would just plug in the terms and I would add the numbers together. Okay. If it's anything larger than that, in this case, 9 terms, I would prefer to use the sum formula just because it makes my life a little bit easier and I'm not doing as much work in the long run. So the first thing I want to do is I want to substitute I equals 1 to find my first term. So instead of I'm going to substitute 1 in. 2 times 1 gives me 2, minus 6 is -4. So that tells me my first term in my sequence is -4. I'm going to do the same thing with the top term on the sigma notation, which tells me how many terms are in my series. So my last term is 9. It's the 9th term. So I substitute 9 in. 2 times 9 is 18. 18 minus 6 is 12. So I have my first term and I have my last term. The next thing I need to do is figure out what my common difference is, or how many terms that I have. Okay, so if I was trying to figure out my common difference, okay, I could figure it out by looking at, I would probably do my first term and then my second term and figure out what the common difference is that way, if I needed to put it into an explicit formula. Okay. I substitute the values that I know in the sum formula. I found my first term, I found my last term, I know there's 9 terms. So n equals 9, a sub 1 is -4, a sub n is 12. So -4 plus 12 gives me 8. 8 times 9 is 72. 72 divided by 2 is 36. So in this case, the sum of 2i minus 6 for 9 terms is 36. How can I write the series 2 plus 9 plus 16 plus ... until I get to 79 using sigma notation? And what is the sum? Okay, so I can substitute what I know into the explicit formula. I know that my last term, a sub n equals 79, which would stand for my last row, and I want to know how many terms there are total in my series. So I'm solving for n. Okay, I know my first term is 2, and I can figure out my common difference by saying, okay, well, I know 2 plus 7 is 9, and 9 plus 7 equals 16, and so on and so forth. Okay, so I substitute those values in, and I'm solving for n because I'm looking for the number of terms in my sequence. So when I do that, I have 79. I'm going to subtract 2 from both sides, and then I'm going to divide by 7. So I have 11 equals n minus 1. I add 1 to both sides to get n by itself. So I have n equals 12. This tells me that there are 12 terms in my series. Now, of course, you can sit here and go through and go, okay, my first term is 2, my second term is 9, my third term is 16, on and on until you get to 79. You can do it that way as well. Again, this is more of a shortcut. So you've got, use the formulas that you know to help you figure out the solution. Okay. I'm going to write the explicit formula for the series. Okay. I know my first term is 2. I know my common difference is 7. Okay. Now I'm going to simplify it. Okay, so all I'm doing is I'm multiplying that 7 through. 7 times n is 7n. 7 times 1 is -7. So 2 minus 7 gives me the -5. This is where I'm coming up with my rule for my sigma notation. Again, my first term is that I on the bottom. Okay, there are 12 terms in my series, which is my top number. I can then find the sum of the series. I know my first term, I know my last term, I know how many terms there are. I substitute those numbers in and I get 486. Okay, so the sum of the series in this case is 486. Okay, you can also use a finite arithmetic series. A pyramid of cans is on display in a supermarket. The top row has 1 can, the second row has 2 cans, the third row has 3 cans. If there are 10 rows of cans, how many total cans were used to make the pyramid? Okay, so again, I know my first. Okay, I can substitute what I know to figure out how many cans are in my 10th row by substituting in 10 for n and solving. 10 minus 1 is 9. 9 times 1 is 9, plus 1 is 10. So there are 10 cans in my 10th row. I can then use that information in my sum by substituting 10 for n 1 for a sub 1, 10 for a sub n, and solving. So I get 55, which means there's 55 cans in my pyramid. Of course, you can go through and count 1 plus 2 plus 3 plus 4 plus 5 plus 6 because your common difference is 1 every single time. So again, summary, explicit formula, recursive formula, and sum of a series. Those are really the 3 important things that you need to know here. You can also use sigma notation. It'll go back and forth between sigma notation and just writing out the series. And that is the end of lesson 4.